I would like to address the small satellites. What are their real capacity and how actually they came to the business, and what is the real merits of that and the challenges in the small satellites. And then at the end I'll touch upon the SRM sat, what they have conceived and developed through the students and launched it, and which is in orbit lasted 2.5 years. It's not a big matter, but anyway, how do we define the small satellites? This is the category which we really follow. So under 500 kg, smaller, 100 to 500, micro is 10 to 100, nano is 1 to 10, and micro is 1 kg. This is what actually this one. And to tell the history, over the last 50 years, worldwide launches more than 860 microsatellites of 110 kg. 680 nanosatellites of 1 to 10 kg and 20 picosatellites of 0.1 to 1 kg. This is the recent history, and today and for the future projections are strong growth in nano microsatellite launches with an estimated range of 121 to 128 in the under 50 kg that will need launches globally in 2020. But with versus 33 in 2012, of course, we stand very poor. Interesting nano microsatellites, if you look at it, the civil, which was actually on the 2000 up to 2012, it is about 59%, and defense intelligence was 8%. You see that actually the present capacity of the small satellite has increased, and defense and intelligence wants more of small satellite use, basically because of cost-effective systems. And the technology is given. What are the technologies given? The strength of small satellites is the function of mass, time, cost, and utility. Because it can be realized in short time, and the cost involvement is less, and the technology is providing that, we go for small satellites, and really the defense and the government is going for it. Innovative use of the latest technologies, that is, Alan Turing has told computer memory will double. Moore's law, transistors on a chip 10 times every 6.5 years. It is held for 40 years, that is true. Similarly, HDD capacity has gone to terabytes. These are all actually some of the technologies which have really made small satellites to come through, and even students can handle it. Revolution in manufacturing process, there is a high volume, density, low unit cost, high reliability. Today COTS has become the new high reliability component. This is one of the board on computer, actually small chip, which is actually flying in ISS. They are using it for some other purposes. So that is the present day technology which has brought the satellite to almost like a ring. Strength of small satellites is with the enormous commercial investments in microelectronics. That is, because of the commercial investment, we can now build high capable, low cost, rapid response. It is the most important thing in the small satellite industry, that is because rapid response, within a year you can get the satellite, quick time, and reliable and operational with the components. So that is small satellites. The applications, if you look at it, small satellites has really scanned through all these. They have recorded data on the terrestrial and space environment, near the moon as well as on Earth. There are moon missions which have gone through. Help in the search for planets on other star systems also. Small satellites are standing rather than higher has demonstrated various telecommunication systems that we enjoy today. As the other lecturers have really pointed out, that store and transmit communication chains, many applications have come through, and today we are going to realize the operational system for remote sensing applications. These satellites have served. Further, what the services really it has given is a test bed for the development of new space technologies and hands-on educational tools for countless students, scientists and engineers, including scientists actually looking into the small satellite technology because they can test their payloads or the instruments within a short period of 1 year rather than waiting for the major mission which will take normally 4 to 5 years. Because the major satellites cannot take risk, so from that angle it is delayed, but here risk averse is there, so small satellites can really bring in the response systems. Low mass, low cost really allows non-space faring nations, corporations, educational institutions and even individuals to low cost access to space. That is the real benefit or the gift from small satellites. Real-time assessment, the proliferation of small satellites will increase our understanding of the near Earth environment and provide nearly real-time assessment of that changing environment. Because today on the climate change and or the atmospheric studies, we want actually real-time realization of the data and the information. For that, the small satellites with the quick response we get through this one. First, economical means, of course, here see, for space exploration, small satellites can provide an efficient and economical means to identify regions of interest before sending larger space systems with more instrumentation. So, best solution is, in the face of the global economic downturn, small satellites are the best solution for stretching limited resources, which is actually the major missions are costly. So that's why actually the stretching the limited resources while accomplishing mission objectives. That is actually what is the advantage of small satellites. Emerging opportunities, of course, this is actually pointed out, and the major missions are doing this one. However, even small satellites can do the job. So military, that is the defense and other thing, civil, commercial, on the polling and on communication side as well as remote side communications, and then high resolution imaging. These are the major applications. What we want actually, as Professor Krishnaswamy has told, is continuing the major programs through the small satellites. So that is what actually getting into the commercial aspect.